Hello, everyone. Today we're going to explore sectioning. Imagine you have a mysterious box and you're curious about what's inside. Wouldn't it be wonderful if you could just slice through it to see its internal features? That's exactly what sectioning allows us to do. In engineering, we use sectioning to create what we call a sectional view by making an imaginary cut through a three-dimensional object. Think of it like cutting through a cake to see all its layers. This technique is absolutely essential in engineering as it helps us understand and communicate the hidden details of complex objects that we otherwise couldn't see from the outside. Now, let's understand why sectioning is so important in engineering. First and foremost, it's like having X-ray vision. It allows us to peer inside solid objects to see holes, cavities, and grooves that would otherwise be hidden from view. Imagine trying to explain to someone how a mechanical watch works without being able to show its internal gears. Quite difficult, right? That's where sectioning comes in. It helps simplify complex designs, making them easier to understand. For manufacturers, these sectional views are like detailed road maps, providing precise information needed for machining and assembly. Most importantly, it serves as a universal language between engineers, manufacturers, and technicians, ensuring everyone understands exactly how the components should be made. Let's walk through the step-by-step process of creating a sectional view. Think of it as following a recipe, where each step is crucial for the final result. First, we need to identify why we're creating the section. Are we trying to show a hidden hole, or maybe reveal how different parts fit together? Next, we select our cutting plane. This is like choosing the angle at which we'll slice through our object. Then comes the fascinating part. We mentally cut through the object along this plane. Imagine you have a loaf of bread. Once you cut it, you remove the front piece to see the inside. Similarly, in sectioning, we remove the front portion of our object. The exposed surface is then marked with special parallel lines called hatching, which help identify the solid material. Finally, we carefully draw this view, making sure to include all the exposed features accurately. Let's focus on some crucial rules that will help you create perfect sectional views. When we create our section, we typically omit hidden lines that are behind the cutting plane. This helps keep our drawing clean and easy to understand. Here's an interesting detail. The hatching lines we use aren't random. Different materials are represented by different types of hatching patterns. For instance, steel might have one type of pattern, while aluminum has another. Think of it as giving each material its own unique signature. And remember, just like in architecture, symmetry and proper alignment are absolutely essential. These elements aren't just for aesthetics. They help ensure that anyone reading your drawing can interpret it correctly. Let's bring our learning to life with some practical examples. Our first example is a cylinder with a central hole, cut vertically. Imagine slicing through a pipe lengthwise. When we make this cut, the circular hole appears as a rectangle in our sectional view. Isn't that interesting? Our hatching lines clearly show which parts are solid material. Our second example is equally fascinating, a cuboid with an embedded sphere. When we cut horizontally through the center of the sphere, what do you think we see? That's right, a perfect circle. This is because any horizontal slice through a sphere creates a circular cross-section. These examples demonstrate how sectioning helps us understand complex 3D shapes through their 2D representations. Let's explore another fascinating example of sectioning, a cone cut at an angle. Imagine holding an ice cream cone and slicing through it diagonally. What shape would you see? When we cut a cone with an inclined plane, we get what mathematicians call a conic section. In this case, an ellipse. This is particularly interesting because depending on the angle of our cut, we could get different shapes. This example beautifully demonstrates how sectioning can reveal unexpected geometrical patterns in everyday objects. Think about it. Every time you cut through a cone-shaped object at different angles, you're creating different mathematical shapes. Now, let's dive into the different ways we can cut through our objects. Just like a master chef has different cutting techniques, engineers have various sectioning planes. First, we have the vertical sectional plane. Imagine cutting straight down through an object, like slicing through a birthday cake from top to bottom. This is particularly useful when we're working with objects that have vertical symmetry, like cylinders or cones. Then we have the horizontal sectional plane, which is like cutting parallel to the ground. Think of slicing a layer cake horizontally. It's perfect for understanding layered structures. Finally, there's the inclined sectional plane, which cuts at an angle. This is especially useful when we need to reveal slanted internal features. Imagine cutting through a staircase diagonally to see its profile. Let's explore some more specialized types of sectional planes. First, we have the offset sectional plane. Imagine a cutting path that zigzags through an object to capture multiple important features that aren't in a straight line. It's like following a treasure map that leads you through different parts of the object. Then there's the partial section, where we only cut through a portion of the object. This is particularly useful when we just want to peek inside a specific area without exposing everything. Finally, we have the revolved section. This is a clever technique where we rotate the sectional view into the plane of the paper. It's commonly used for circular components like shafts, giving us a clear view of their cross-sectional shape. Let's see how these sectioning techniques work in real-world applications. Consider a bolt and nut assembly. By making a vertical cut through its axis, we can clearly see how the threads interlock, revealing their helical pattern. It's like seeing the DNA spiral of our mechanical components. Next, let's look at a pulley. When we section it vertically through its center, we can observe how the spokes connect to the hub, much like seeing the internal structure of a wheel. And for our gear example, a horizontal section shows us the precise profile of the teeth, which is crucial for understanding how gears mesh together. These practical examples show why sectioning is so important in engineering design and manufacturing. Before we wrap up, let's discuss some crucial practical considerations that will help you create effective sectional views. The selection of your cutting plane is like choosing the perfect camera angle. It must reveal exactly what you want to show. Different materials require different hatch patterns. It's like giving each material its own unique fingerprint. Steel might have one pattern, while wood has another, making it easy to identify materials at a glance. And remember, clarity is key. Just like a good photograph shouldn't be cluttered, your sectional view should avoid overlapping lines or unnecessary details that might confuse the reader. We have reached the end of this video today. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.